Dear students, I would like to speak with you about probability. You had studied before in the previous year the concept of a sample, its importance and its type, and you know that the sample is a small part from a large society that looks like the society and represents it well and is selected randomly. The sample should only represent the society, the object of study, and it shouldn't be based on a certain group and neglect the other, so that the results of the study can be near reality and we can make decisions according to these results. So we can generalize these results on the society as a whole. For example, when we hold a survey to know which TV programs are the most effective on the public opinion, the survey can't be applied on all people, but we select a sample representing the society and we perform our investigations on it. Then we generalize the results on all society. Example number one. A pupil carried out a survey on a sample of pupils in his school to know how much they liked mathematics. The sample consists of 30 pupils. The following table shows the results of the survey. The degree of liking math: high degree, middle degree, weak degree. The number of pupils: 15 in high degree, 10 in middle degree, 5 in weak degree. According to the survey, if a pupil is chosen randomly from the school, what is the probability that the pupil likes math with high degree? What is the probability that the pupil likes math with middle degree? What is the probability that the pupil likes math with weak degree? If the number of pupils in this school is 1,200 pupils, then what is the expected number of pupils who like math with high degree? Solution: the probability that the pupil likes math with high degree equal the number of pupils who like math with high degree over the number of all pupils in the sample equal 15 over 30 equal half. Number 2. The probability that the pupil likes math with the middle degree equal the number of pupils who like math with middle degree over the number of all pupils in the sample equal 10 over 30 equal 1 over 3. Number 3. The probability that the pupil likes math with weak degree equal the number of pupils who like math with weak degree over the number of all pupils in the sample equal 5 over 30 equal 1 over 6. Number 4. In the selected sample, we obtained that the probability that the pupil likes math with high degree equal half. Then it is expected that half the number of the pupils in the school like math in high degree. It implies the expected number of pupils who like math in the school with high degree equal half times 1,200 equal 600 pupils. Probability. You had studied before the experimental probability and the theoretical probability, and you know that the experimental probability depends on performing an experiment. Then we register the outcomes Then we use these outcomes to calculate the probability of occurrence of one of these outcomes using the relation the probability of occurrence of a certain event equal the number of times of repeating this outcome over the number of all possible outcomes. It is noted that the more we carry out the experiment, the more we obtain an accurate value for the probability. The expected number for occurrence of a certain event equals the probability of its occurrence times the total number of the given individuals. The theoretical probability depends on equivalent chances. It implies all individuals have the same chance to occur. For example, when we toss a fair coin and observe the apparent face, then we find one chance or two chances will occur, either head or tail. When we roll a fair die and observe the number on the upper face, then the chance of appearance of each face is the same. The event it is a subset of a sample space. For example, if A is the event of appearance of an odd number when we throw a fair die once and observe the apparent number on the upper face, then set E is the set of elements 1, 3, 5, and E subset of S, and it is said that A is an event in S. Generally, the probability of occurrence of an event E subset of S is denoted by P of E. It is found by using the relation P of E equal the number of elements of E over the number of elements of the sample space equal N of E over N of S. If a fair die is thrown once and we observe the number on the upper face, find the probability of each of the following events. E is the event of appearance of a number greater than 4. B is the event of appearance of an even number. C is the event of appearance of the number 5. D is the event of appearance of the number 7. E is the event of appearance of a number less than 7. Solution S equal the set of elements 1, 2, 3, 4, 5, and 6. N of S equal 6. 1. E equal the set of elements 5 and 6. N of E equal 2. Therefore, P of E equal 2 over 6 equal 1 over 3. Number 2. B equal the set of elements 2, 4, and 6. N of B equal 3. Therefore, P of B equal 3 over 6 equal 1 over 2. Number 3. C equal the set of element 5. N of C equal 1. Therefore, P of C equal 1 over 6. Number 4. D equal 5. N of D equal 0. Therefore, P of D equal 0 over 6 equal 0. Impossible event. Number 5. E equal the set of elements 1, 2, 3, 4, 5, and 6. N of E equal 6. Therefore, P of E equal 6 over 6 equal 1. 13 event or sure event. Remarks. The impossible event is the event which has no chance for occurring. It implies the probability of the impossible event equals 0. The certain event is the event whose outcomes are all possible. It implies the probability of the certain event equal 1. The probability of any event isn't less than 0 and it isn't more than 1. For any event E, P of E greater than or equal 0 and smaller than or equal 1. It implies P of E belong to the closed interval 0 and 1. A bag contains an amount of marbles of the same size and softness. If 2 marbles are red, 3 marbles are blue, and 5 marbles are white, a marble is drawn randomly. Calculate the probability that the drawn marble is red, the probability that the drawn marble is blue, the probability that the drawn marble is white, the probability that the drawn marble isn't blue. Solution. The probability of getting a certain occurrence equals the number of chances of getting this occurrence over the total number of chances. Since the total number of marbles equal 2 plus 3 plus 5 equal 10 marbles, number 1, the probability that the drawn marble is red equal number of red marbles over total number of marbles equal 2 over 10 equal 1 over 5. Number 2, the probability that the drawn marble is blue equal number of blue marbles over total number of marbles equal 3 over 10. Number 3, the probability that the drawn marble is white equal number of white marbles over total number of marbles equal 5 over 10 equal 1 over 2. Number 4, the probability that the drawn marble isn't blue equal number of marbles which aren't blue over total number of marbles equal 10 minus 3 over 10 equal 7 over 10. Remark, in the previous example, notice that P of the marble is red equal 2 over 10. P of the marble is blue equal 3 over 10. P of the marble is white equal 5 over 10. Since 2 over 10 plus 3 over 10 plus 5 over 10 equal 1, it implies the sum of probabilities of all outcomes of the sample space equals 1. Then the probability that an event A doesn't occur is 1 minus P of E. According to this, we can find the probability that the drawn marble isn't blue as follows. The probability that the drawn marble isn't blue equal 1 minus the probability that it is blue equal 1 minus 3 over 10 equal 7 over 10. In a class, some pupils wear glasses and others don't wear glasses. If one pupil is chosen randomly from this class and the probability that the pupil wears glasses is 0.1, find the probability that the pupil doesn't wear glasses. Number 2, if the number of pupils in this class is 30 pupils, find the expected number of pupils who wear glasses. Solution. The probability that the pupil doesn't wear glasses equals 1 minus the probability that the pupil wears glasses equal 1 minus 0.1 equal 0.9. Number 2. The expected number of pupils who wear glasses equal 0.1 times 30 equal 3 pupils. factory of electric sets produces two kinds of televisions. In order to change the amount of production due to the request of shopping market, a sample is formed from 50 TV sets from 5 shops randomly. Its data was as follows: index of shop 1, 2, 3, 4, and 5. Number of sold TV sets from the first kind 30 in the first shop, 42 in the second shop, 24 in the third, 15 in the fourth, 40 in the fifth. Number of sold TV sets from the second kind 20 from the first shop, 8 from the second shop, 26 from the third shop, 35 from the fourth shop, 10 from the fifth shop. Which kind is more requested, and what is your advice to the factory? If the total production of this factory is 3000 TV sets, what is the expected number from the first kind?